Page 3, let's do this. Now, we're coming across a new form now. Look on problem 7. Whoops. Standard form. Y is not by itself anymore. This form is ax plus by equals c. Okay? Standard form is all about finding intercepts. Once you find the x-intercept, once you found the y-intercept, all you have to do is plot those points and connect them, and you have a line. The thing about an x-intercept is that it crosses the x-axis, and it always has a y value of 0. Always. No matter where it is on the axis, it always has a y value of 0. So what that means is we can take that 0, because we know y is going to equal 0, and plug it in for y. Okay, so basically what we would have is 4x plus 0 equals -6. Now you have a small equation to solve. 4x equals -6. Divide both sides by 4 to solve as normal. I can't do wrong. It's okay. You'll be fine. You get -6 over 4, which is -1.5. That means you have an x-intercept of -1.5, comma 0. That means you have an x-intercept right around in... Oh, bull honky. It's right between the 1 and the 2. Maybe I can zoom. Can I zoom on this? Oh. Oh, I can. No. Oh, let's go. Okay. I just found an x-intercept of -1.5. So I'm going to plot that point. -1.5. It's a point that I found. Okay. How do I unzoom? How do I unzoom? Ooh, nice. Okay. Now, make sure you have that copied. I'm going to clean it up so I can find the y-intercept now. So we found x-intercept. What the heck? How do I erase it? Anyways, okay. Y-intercept I'm going to do in red. Okay, y-intercept is along this axis right here. It's always going to have an x value of 0, no matter what. So what that means is, in my equation, I can say that x is going to be 0. In reality, you might already kind of pick this up, but basically, when you plug in 0, it goes away, because it just equals 0. This is a very simple equation to solve. You get y equals -6. That means you have a y-intercept of -6. 1, 2, 3, 4, 5. Oh, what just happened? 1, 2, 3, 4, 5, 6. You have 2 points now. The 2 points you found are -1.50 and 0, -6. You can connect those for your line. At least it wasn't messy, right? Sorry about that. I don't know why it won't erase. It's ridiculous. Oh well, I'm learning. Anyways. That's problem 7. Problem 8, another way to think about this is think, oh well, it's kind of in slope-intercept form, y equals mx plus b, because the y is by itself. But there's something missing. There's no mx term, there's like no x's there. So you can write that there's no x's there, but there is a minus 4. That might help you, because then you see I do have a y-intercept of negative 4. So I'm going to plot that. Plot that. Y-intercept of negative 4. 1, 2, 3, 4. And the next question is, what's a slope of 0 mean? If you remember, a slope of 0 is a flat line. Junk. Why did it do that? And a flat line looks like that. Okay. Another way to think about it is when you have y equals negative 4, that means you want to have a line where y always equals negative 4. On this line, no matter where you're at, it will always have a y value of negative 4. Let's move on. Write an equation of a line in standard form with the given slope and y-intercept. And on this review, I kind of give you a little hint that it helps to write it in slope-intercept form first. A lot of times that's the easiest form to write right away, because look what it gave you. It gave you m and b. I know what you're thinking. Y equals mx plus b. So let's write it. Y equals 1/3 x plus 2/3. Now, if you remember, my goal was to write it in standard form. Ax plus by equals c. But standard form has kind of some weird rules, remember. One of them being you cannot have fractions in standard form. So this 1/3 and 2/3 is not going to fly. So if you remember, what I do to get rid of that fraction is multiply by the denominator. I multiplied everything times 3 because that was the denominator. So this is what I come up with. 3y equals 1x, because all that happens is my denominator cancels out with what I multiplied by, plus 2. The 3's canceled out. I just have the 2 now. Okay, but if you notice, standard form has the x's and y's on the left side of the equation. So I need to get this x over to the left side. Okay, there's no magic in algebra. I just have to follow the rules that if I want something to move to the other side, I'm going to have to subtract it from this side and subtract it from this side. Because what will happen? They'll cancel out from the right side, which is what I want, and it'll show up on the left side. Careful here with how you write this. I'm going to list it as negative 1x plus 3y, just so it looks more like my form that I'm trying to get to. So you're probably thinking, yes, I'm done. This page is over. I wish. There's one more little negative, little dumb rule that your a value cannot be negative. So negative 1 here is not okay. Well, how do I get rid of it? Again, you're going to multiply the whole equation by something. Multiply everything by it. To fix a negative, make everything the opposite, just multiply by negative 1. Because what that does, it flips all signs to the opposite of what they were. And there you go, 1x minus 3y equals negative 2. Whoops, forgot. Problem 10. Table shows the cost of a ski rental package for a given number of people. The rate of change, why does that sound familiar? Rate of change is slope. Explain what the rate of change means for this situation. Okay, well, slope, remember there's a couple different ways we remember slope, rise over run. Also, it's where you subtract the y's on top and you subtract the x's on bottom. That's what we're going to do for this exact table here. We have a list of x values and we have a list of y values. We're going to take 2 of the x's, 2 of the y's, subtract the y's on top, subtract the x's on bottom, and call it a day. So basically I'm going to say this is x1, this is y1, this is x2, and this is y2. Y is on top, 150 minus 210. X is on bottom, 4 minus 5. I get negative 60 over negative 1, which is equal to 60. So that is the rate of change. The problem asks for the rate of change, and I found it, 60. Because rate of change is slope, and slope is where you subtract y's on top, x's on bottom. Now, this last part, explain what the rate of change means. Okay, so you got to think about what's actually happening here. You and your squad are going skiing. When there's 4 of you, it costs $150. When there's 5 of you, it costs $210. When there's 6 of you, it costs $270. What do you notice about the cost? It keeps going up, obviously. But how much is it going up? What is the rate of change? It's changing at $60 per person. So when it asks you to explain, what you'd write is a quick blurb that rate of change means that for every person being added, $60 is being added to the cost. That's what the rate of change means for this problem. Now I'm done with page 3.